Okay, let's do a one-way ANOVA. The way that an ANOVA works is you can have more than two groups, and you can look at whether those groups overall are different on the dependent variable. So we're going to use the braincandy.sav file, and we're going to use this to get some idea about what's going on with three different conditions here. So you can see we're in the variable view tab now, and we have a person variable. This is just assigning a number to each person, the dose variable, and this is the independent variable, which has more than two levels. And we'll take a look at what those are. See, because we can see that the label here is dose of drug. That just means that we're manipulating the dosage that people get, not just drug versus placebo. And if you click here, values, you can see I've already labeled the different levels, right? There's a little hidden thing right here. If you just click in this corner of the values cell, it pulls up this value labels window. So you can see here that there's three conditions. Placebo is number one, low dose of the drug is number two, and a high dose of the drug is number three. Okay, so those are all labeled and ready to go. And then we're going to say that these drugs are supposed to affect happiness or mood. And so we have a variable here called happiness, and this will just be the self-reported happiness that people report in a survey. Now let's go ahead and look in the data view, and we can see here not too many people, just 15 people, and you can see here the numbers for dose, 1, 2, and 3. And again, if we click this button here, the A1 button, that'll put our labels in there. So sometimes that helps keep track of things. Okay, so actually doing a one-way ANOVA is real easy. You go up to Analyze, where all of our statistical tests are, down to Compare Means, and then we're going to click One-Way ANOVA right there. And all we have to do now is move our dependent variable into the dependent list using these handy little arrow boxes. And then the dosage, this is our independent variable, our conditions, are just going to go in factor. Now, the nice thing about this is that unlike a t-test where you have to specify which number goes with the two groups that you're comparing, SPSS just assumes that there are all of the levels available to you. Okay, so it'll just read in any number here, which can be tricky. If you accidentally put the wrong thing in here, you'll get really messy results if you have a whole bunch of different values, but all you have to do is put it in there. Okay, one other thing to note is that we can do contrasts and post-hoc tests. So contrasts are planned comparisons. If we go in there, we can see that this is where we assign those contrast codes. So if you have a specific prediction about what two groups are going to be different from each other, or you have a prediction about two of the groups being different than one of the groups, you can look at other resources to figure out why we would do a lot of these. But let's say we want to just compare the placebo group to the highest dose possible. Maybe that's the biggest difference. So we will just go ahead and put in our contrast, -1, 0, and 1. And again, if you don't know what these numbers mean, you can review other information about planned comparisons. But if you're following along, this should make sense. Go ahead and click continue. All right, in the post hoc box, this is what you're going to do if you don't have specific planned comparisons. Okay, this is what you do when you just want to explore which of the conditions are different from each other, which of the groups are different from each other. Let's go ahead and just choose Scheffé test because it's a reasonable test. You have obviously a lot of options, but we'll stick with Scheffé for now. And click continue. Now the last thing that you should do, no matter whether you're doing contrast or post hoc, you might not even want to be doing either of those, but you should click on descriptives in the options box. Okay, so I went ahead and clicked this options button and checked descriptives. You have other things available, but as far as we're concerned, we're not going to worry about this right now. And click continue. All right, so we're all set up. We click OK, and everything runs, and we have all of the information we need. Now, to go through what we actually learned from this, the first table is all of our descriptives. So we can see in each group what was the mean of the DV, what was the standard deviation, and then other things like standard error, confidence intervals. Minimum, maximum just tell you the lowest possible and highest possible numbers in each of those groups. So that'll be helpful when we report our results. We see our mean overall as well, but it doesn't tell us too much about what happened. Do the groups statistically differ? That's what we use the ANOVA table for. All right, and here's the ANOVA table. Here's all the stuff. Most of this is not going to be super helpful to us. What we really are going to zone in on is this F ratio here. And we can see that 5.119 is bigger than 1. We're looking for bigger than 1 in an ANOVA. And we can see here that the significance is 0.025. Right? So P equals 0.025 for this analysis of variance, which means we have a significant effect here. There's the between group variance is bigger than the within group variance to a degree that we say that there's something different about those groups. Okay, so overall, this is our omnibus ANOVA test. This F ratio just tells us that the IV is affecting the DV. The differences between groups, it's there. There's some difference, but we just don't know where it is quite yet. That's why we move on to the next part. So I'll scroll down so we can see the next bit of this, the contrast coefficients. All right, so here's our -1, 0, and 1. These are how we labeled that we were saying we want to compare placebo to the high dose condition. We're going to leave low dose out of it for now. And here are the results of that. Okay, so the contrast test tells us this looks just like a t-test, but a little bit different, handles things a little bit differently, but on the interpretation end, you're going to interpret this the same way you would a t-test. So t is equal to 3.157, looking decent, and we can tell significance here is there. Okay, so it's less than 0.05, it's less than 0.01 even. P is equal to 0.008 in this case. So we can conclude that the happiness is higher. We can check our means to see how it went. All right, happiness is higher in the high dose group compared to the placebo group. Okay, a difference between 5 and 2.2, and this contrast test tells us that that difference is significant. Okay. Okay. Final thing, what about the Posthoc test? Maybe we didn't know that we were going to plan out placebo versus high dose, and we just wanted to go ahead and look at everything. This is our Posthoc test, our Chaffee's test, and this is going to give us the analysis of every group compared to every other group. Okay, in this case, we can make 3 total comparisons, but it's going to go ahead and duplicate it because it's placebo to low dose is going to be the same as low dose to placebo, but it's going to show you everything. And from this, we can see there's only one significant difference, and lo and behold, it's the one that we tested in our planned contrast. So high dose is different than placebo, and here the significance is 0.027. Right? You're going to find that your significance levels are higher, or in other words, the p-value is bigger in post-hoc tests compared to the planned comparisons because multiple comparisons give us type 1 error and post-hoc tests try to control it. Okay, so it makes it harder to find a significant effect. In this case, the effect was so big that we had no trouble finding it even with this post-hoc test, which gives us confidence that that's a real difference. Okay, that is it. You can see here from the other post-hoc tests that the other groups were not different from each other. P is equal to 0.17 or 0.547. And so we can't conclude a difference there. One thing I want to point out with the One-Way ANOVA is how valuable it can be to graph a result like this. And so to remind you, we're going to go up to Graphs, click on Chart Builder, and this is just going to come up. I'll check the box, but I tell you, it comes up every time. And here is our chart builder. Okay, so in this case, we're still just going to use bar graphs because we're comparing just 3 groups to each other. Bar graphs are good for that. And so I click and drag this simple bar graph into the main window. And on the x-axis, we're always going to have our independent variable. In this case, it's the dose of the drug. Throw that in there. And then happiness is our dependent variable, so we'll put that on the y-axis. And that looks fine. Click OK. And there is our graph. Okay, so pretty much what we thought we had. High dose is the highest level of happiness. Placebo is the lowest. We know from both of those tests, the planned comparison and the post-hoc, that this bar is bigger than this bar statistically, but these other comparisons, even though they look different, aren't reliable. They're not statistically significant. So we can't say for sure that the low dose really helps. And we can't say for sure that the high dose is way better, is statistically better than the low dose, but what we do know is that at least compared to nothing, having this high dose definitely is influencing happiness. Okay, so this graph is helpful to visualize the results of your ANOVA, and that's all it is. So now you know how to do a one-way ANOVA.